Hello and welcome to Udacity Webcast, Ruby Data Structures Hashes. Today we'll be looking specifically at Ruby's built-in hash methods, but we'll be doing an overview of what a Ruby hash is and what its structure looks like. Firstly, it's important to remember that Ruby has many data types. We have strings, numbers, which are floats or integers, arrays, hashes, symbols, and Boolean, true or false, and nil. Today we'll be looking at hashes. What is a hash data type? A hash is a dictionary-like collection of unique keys and their values, also called associative arrays. They are similar to arrays, but where arrays uses integers as its index, a hash allows you to use any object type. Hashes enumerate their values in the order that the corresponding keys were inserted. So what's that actually mean? So let's look at the way an array is structured. So arrays are ordered integer index collections of any object. When examining elements within an array, elements are ordered by their index. Element 1 is located at index 0. Element 2 is located at index 1, element 3 at index 2, and element 4 at index 3. All indices start at 0, and this is an example of where order matters. So a hash is a dictionary-like collection of unique keys and their values. So in order for us to access the value that is associated with a key, we'll have to call on that unique key, and the value will be returned. There are essentially four things that you'll be doing with a hash. You'll be inserting, which adds a key and an associated value, or a key-value pair. You'll remove, which deletes a key and its associated value, or a key-value pair. You'll search, accessing a key to find its associated value. And you'll modify, edit a value of an existing key-value pair. Let's look at this in action. Let's examine how we would insert a key-value pair into a hash and compare it against how we would insert an element into an array. So here we have a variable named toyArray, which points to an array of two elements, a string at the 0 index, product, and a number at index 1, 20. If we wish to insert a third element into the array, we would essentially just call on the toyArray, hard brackets 2, and assign the second index in the array, index number 2, to be yo-yo. Now toyArray will contain three elements, the string product, 20, and the string yo-yo. Here we have a toy hash, which has one key-value pair, product as a string and key, and 1 as its value. To insert a new key-value pair into that hash, we essentially call on the variable named toyHash, hard brackets, name the new key, in this case a string item, and assign it to have a new value, which is in this case a string yo-yo. How do we remove or delete elements from a hash? And let's compare that against how we would do so in an array. Here we have a toyArray that's made up of 4 elements. A string product at the 0 index, the number 20 at the index 1, the string item at index 2, and the string yo-yo at index 3. We can call on Ruby's built-in array method, delete, and pass it the argument yo-yo. Alternatively, we can call on the Ruby built-in method delete@, and pass it an index. What we're left with is the toyArray is now made up of 3 elements, product at the 0 index, 20 at index 1, and item as a string in index 2. Here we have a variable toyHash, which points to a hash that has 2 key-value pairs, product as a string and key with a value of 20, and item as a key and string with a value of the string yo-yo. We can call on the built-in Ruby hash method, delete, and pass it the key name of item. toyHash now has 1 key-value pair, the string product as a string and key with a value of 20. Let's examine how we would search for elements within a hash and compare that against how we would search for an element in an array. Here we have a variable toyArray, which points to an array of 4 elements. Product as a string, 20 as a number, item as a string, and yo-yo as a string. If we don't explicitly know the index at which our element is located at, we'll have to search through every index of this array to see if it exists. Here we've defined a variable target and assigned it to equal the string yo-yo. We're going to iterate over each and every index of this array using Ruby's built-in array method, each with index. Inside the pipes, we've defined element and index. We've set a conditional if the target is the same as the element, then return the index. Index 3 is returned. Now let's examine how we would search for an element in a hash. Here we have a toy hash, which is made up of two key value pairs. Product as a string and key, and 20 as its value, and item as a key, and yo-yo as its value. We simply examine the toy hash and examine the key of item, and it returns the value of yo-yo. Notice the syntax here. We're using hard brackets, placing the key as a string inside of these hard brackets, searching for a key as string within the toy hash. If that key did not exist within toy hash, a nil value would be returned. Let's examine how we would modify an element in a hash and compare that against how we would modify an element in an array. Once again, we have a toy array, which is pointing to an array of 4 elements. Product as string, 20 as number, item as a string, and yo-yo as a string. If we examined the index 1 of this array, 20 would be returned. To reassign this value, we simply call on toy array index 1 and reassign its value. Now toy array is made up of 4 elements. Product as a string, 21 as a number, item as a string, and yo-yo as a string. Here we have our toy hash with 2 key value pairs, product as a string and key, and 20 as a value, item as a string and key, and yo-yo as a value. To modify a value, we simply call on that key and reassign its value. So here we have toy hash, hard brackets, calling on the key as a string item, and using the assignment operator, assigning a new value of red yo-yo. So now toy hash is made up of 2 key value pairs, product as a string and key with 20 as its value, item as a string and key, and now red yo-yo as a string value. Let's look at some different hash structures. Again, a hash is a key with an associated value, and these values could be made up of multiple different elements. Here we have a toy inventory hash with a series of different keys: water balloon, silly putty, paint kit, Mr. Potato, ball, Pez, Gumby, array, and hash. The values that each of these keys holds are very different. Water balloon has an integer as its value, silly putty has a float, paint kit has a string, Mr. Potato has a nil value, the key of ball has a symbol as its value, Pez has a Boolean value of true, Gumby has a Boolean value of false, the array key has a array as its value, and the hash key has a hash as its value. We can also have nested hashes and nested arrays as values. Here we have a toy line hash with a key of potato head series, which has as its value a series of key value pairs. Within those key value pairs, we have a toy line toys, which has a value of an array. We can also have symbols as keys. So here we have a variable toy, which points to a hash. The key of title is a symbol with a value of a string, Lego, Iron Man versus Ultron. Similarly, brand, stock, and full price are all symbols, each pointing to a different type of value. So, what can be used as a key? Strings, numbers, floats, integers, arrays, hashes, symbols, Boolean values, true or false, or nil. Any of Ruby's data structures can be used as keys within hashes. What can be stored as a value? Once again, strings, floats, integers, arrays, hashes, symbols, true, false, nil. These can all be stored as values. Let's take a moment to examine using strings and symbols as keys. So a string can be used to act as a key with an associated value within a hash. Double quotes can be used to define this string key value, or single quotes can be used to access this value. We simply call the name of the hash and pass it the string, which is its key, and it will return its associated value. Let's examine using keys as symbols. A symbol can be used to act as a key with an associated value in a hash. The syntax: symbols are generated using the :name and :string literal syntax. That means that a hash can have a symbol :value syntax, or a hash can define the key as symbol by using quotation marks followed by a colon followed by a value. Now let's examine keys as symbols. A symbol can be used to act as a key with an associated value in a hash. They are generated using the :name and :string literal syntax. Here we have a hash with a key defined as symbol key, followed by the value. Alternatively, we can place within quotation marks any series of characters, end quote, followed by its value. To access a value that's associated with a key that is a symbol, we can call in the name of that hash followed by hard brackets, colon, and the symbol key. So a question often comes up about the difference between strings and symbols. And this primarily comes down to an issue of memory concerns. Strings can be changed, and for each string, multiple instantiated objects are created. With symbols, a symbol is immutable. It's a single instantiated object. So what does that mean? So here on the left-hand side, we have a series of strings. String 1 example points to quotation marks, characters, string, end quotes. This string is an instantiated object from the class string. This is an object, and so we're able to call on the object ID of this particular instantiated object. If we'll notice, this long number is returned, ending in 5020. Here we have string 2 example, and we point it to quotation marks, string, same characters as we did above. But when we call object ID on it, we get back a very different number, ending in 9420. We do this once again, string 3 example, pointing to quotation marks, string, and call .objectID method on it, and it returns to us, once again, another very different number, ending in 0440. What this shows us is that for each time that we declare a new string, we're actually instantiating a new object. Now, let's take a look at the symbols. Here we have a variable, symbol 1 example, and we're pointing it towards colon symbol. Now we're calling object ID on symbol 1 example, and we get back this number. This number ends in 5868. We're going to do this again. Symbol 2 example points to a colon symbol. Symbol 2 example.objectID returns to us that same number, ending in 5868. Symbol 3 example points to colon symbol. We call symbol 3 example.objectID, and that very same object ID number is returned to us. What this shows us is that colon symbol is one single instantiated object. A bit more terminology. We have the fat comma, the hash rocket, or the fat arrow. I ordinarily call this the hash rocket. Here we have a variable hash rocket, which is equal to open curly braces, a key of string as a string, pointing to a value using the hash rocket syntax. To access this value, we simply call on hash rocket. Within the hard brackets, we place that key and we have the value returned to us. Using the hash symbol, here we have a variable named hash symbol, which points to a hash with symbol key as a symbol, which has an associated value of the string value. To return this value, we simply call on that variable hash symbol, and within the hard brackets, colon, symbol key, close hard brackets. Now let's take a moment to talk about accessing values within nested hashes. So as we saw before, a key can have any number of different data types as its value, including a hash. So here we have a toy line hash and a target. The target is an array. Finn the human and Jake the dog are two elements that are contained within this target element, which is an array. Here we have two top-level keys, Potato Head series and Adventure Time series. Adventure Time series is a key which, as its value, has a hash with two nested key values. If we call on toyline hash and pass it the key of Adventure Time series, what we'll get back is that hash with toyline as a key and Adventure Time series as a value, and toyline toys as a key, and an array of Finn the human and Jake the dog as its value. But we're interested in the nested value. Specifically, we are interested in this nested value of the array of Finn the human and Jake the dog. We can access this nested value by calling on toyline hash, hard bracket Adventure Time series, hard bracket toyline toys, which will return to us that nested value. Once again, a hash can contain any number of different data types. As a value, how do we access values in a nested array in a nested hash? So here we have a nested array in a nested hash with a target of Finn the human. Here are our two top-level keys. We're interested in values that are assigned to keys nested within Adventure Time series. Here we have toyline hash with a key of Adventure Time series. The return value is a hash with 2 key value pairs. Once again, we're interested in one of the nested values, specifically the one that's associated with toyline toys, which has as its value Finn the human and Jake the dog. So we've gained access to toyline hash with a key of Adventure Time series. Return 2 key value pairs. We'll access one of them specifically, toyline toys. What's returned to us is an array of Finn the human and Jake the dog. Now at this point, we're going to be dealing with an array, and we're only interested in one of its elements. In this specific case, we're interested in the first element, the element that lies at index 0. Hard bracket 0, which will return to us Finn the human, our target element. So here we have another complicated data structure for which we want to access a value in an array of hashes with a nested hash with an array. So our target here is Mr. Potato Head, which is located in an array which is associated with a key, which is a value that's part of Mr. Potato Head series. Here we have index 0 and index 1, 2 separate hashes. We're interested in the hash that's located at index 0. If we call on toy align at index 0, we get back this one single element, which is a hash, which contains a key of Potato Head series. And as its value, we have a nested hash with 2 key value pairs. Toy line as a key with a value of Potato Head series, and a key of Toyline toys with a value that is an array of 2 elements. So Potato Head series is our top level key. We're going to investigate for this nested value of Mr. Potato Head and Potato Bug that are contained within an array. And we're going to specifically be interested in Mr. Potato Head that's located at index 0. So we have toyline array, index 0, which gives us that first initial hash, calling on the key of Potato Head's series. From that, we have 2 key value pairs that are returned to us. We're only interested in one of those key value pairs, which is toyline toys. And of that return value, which is an array, we're only interested in the very first element of that array at index 0. And we have Mr. Potato Head returned to us. So we can compare hashes. Here we have toy hash 1 and toy hash 2. They contain identical keys, but each of those keys have different values. So if we call toy hash 1 and compare it against toy hash 2, we'll have a value returned to us of false. Here we have toy hash 3 and toy hash 4, which have identical key and value pairs. So toy hash 3 compared against toy hash 4, we have a return value of true. Those are identical. Okay, so we're going to transition here and start talking about some built-in Ruby methods for hashes. First, I'd like to talk about the Ruby built-in hash method .keys. This returns a new array populated with the keys from this hash. So here we have a toy hash 1, which points to a hash with a series of key value pairs. If I call toy hash 1.keys, it'll return to me an array of all the keys that are associated with that hash. .keys will not return to you any nested keys. Here we have a variable toy hash 2. It points to a hash with 2 key value pairs, Potato Head series and Adventure Time series. These are top level keys. Each of these keys have as its value a hash with 2 nested key value pairs. In order for me to gain access to Toyline and Toyline toys as keys using the .key built-in Ruby hash method, I'll need to access those nested elements. In this case, toys hash 2 hard brackets Adventure Time series .keys will return Toyline and Toyline toys as an array with keys from that particular nested hash. Another built-in Ruby method for hashes is .hasKeys. It returns true if the given key is present in the hash. Toy hash 1 is a hash with a series of key value pairs. If I call .hasKeys on toy hash 1 and give it an argument of the string title, it will return true because that key does in fact exist within toy hash 1. Another built-in Ruby method for hashes is .values. It returns a new array populated with the values from a hash. So toy hash 1 has a series of key value pairs. If I call that method on toy hash 1.values, it will return to me an array of Finn the human, Adventure Time series, the string 40, true, and 32. Those are all the values that are associated with that hash. Let's take a moment to talk about the built-in Ruby hash method .each. It calls on a block once for each key in the hash, passing the key value pairs parameters. So here we have toy hash, which is a series of key value pairs. On toy hash we call .each do. Inside the pipes we declare a value and we p out that value. It will p out each of the values associated with that hash. On the right hand side we have toy hash.each do. Inside the pipes we actually declare two variables, a key and a value, and we're able to print out both the key and the value. In this case we've decided to string interpolate them. Let's take a look at the built-in Ruby hash method empty. Returns true if hash contains no key value pairs. So here we have a variable toy hash, which points to a hash with a series of key value pairs. And we have a variable empty toy hash, which is equal to an empty hash. We call toy hash.empty, returns a value of false because it does indeed have a series of key value pairs. And on empty toy hash variable, we call .empty, and it of course returns true, for there is no key value pairs associated with that variable. We're going to examine the built-in Ruby method .flatten. It returns a new array that is one-dimensional, flattening of the hash. So here we have a toy hash, which is a series of key value pairs. On that toy hash, we call the method flatten, and the return value is an array with both the keys and the values as a series of elements within this array. Here we'll be looking at the built-in Ruby hash method .merge. It returns a new hash containing the contents of other hash and the contents of hash. So we have two hashes here defined, toy hash 1, which has a key of product and a value of 1, an item as a key with a value of Rubik's Cube, toy hash 2, which has toy line as a key and hypercubed as a value, description as a key, and can you line it up as a value. We call toy hash 1.merge, passing it as an argument toy hash 2, and we end up with a single hash with a series of key value pairs that is the combination of those two hashes. And finally, we're going to be looking at the built-in Ruby hash method .clear. It removes all key value pairs from a hash. So again, for a final time, we have a toy hash which is equal to a series of key value pairs. We call toy hash.clear, and the return value is an empty hash. I encourage you to go to RubyDocs to investigate and experiment with built-in Ruby hash methods. Here's a listing of some of the ones that I find most interesting. Thank you for your time. Happy hacking!